G'day guys. It's nearly 10:30 here at night. I'm still working on detectors for people. Fantastic. Anyway, I've got this 6 here, and this 6 has not had the microphonics issue, if it's got one. I couldn't really tell, not in the workshop anyway. But yeah, I was having a look at it, and if you want to know what they do when they fix the microphonics issue, I'll get something nice and pointy to poke at it so you know. On the board here, you see these two inductors, one there and one there. That is what is replaced. The ones that go and get that issue dealt with, I think I've done it in another video. I've shown them that after they've done it already, it'll be in a GPX6000 video of some description in the past. I don't know, maybe 20 videos ago or so. But these are replaced for what I can tell. I've actually got pictures on the computer. Those inductors there are replaced for low profile ones. So those are they're all probably black. And I'm not sure on the value. I'm gonna take these out and check the value of these. I think they might be 2.2 or 2.7 microhenries. I'm not sure. And it's part of the DAC audio system there, or the audio output. So you can alter the inductance value a little bit there. You might get better smoothing, or it just might have some slight effect on the audio quality. I wouldn't go changing those values too much, but you possibly, depending on the clock rate, speed, its smoothing capacitors and things like that, you can have a look at it. Maybe what you want to do is you want to have a look at the chip. It's got the number on it there, and go look up the specs on it and have a look to see what you can get away with if you want to. Because I have noticed with these detectors, with a more, what I would classify as a more, even though it's digitally derived, but it's got a more analog feel to it in the older detectors, where a lot of these digital DAC type output on the audio sounds very robotic. It doesn't have a lot of tonal information. So when you go over a target, sometimes, like, I know, I'm not going to say myself because I just don't get out as much anymore, but I do know guys who can actually, with the older detectors, say that's lead, that's gold, and they'll be right 90% of the time, if not all the time. I do actually know people that can do that. With these detectors, that they tell me you haven't got a hope in hell. So that's the story. Now I'll just go and have a look on my other computer here, just so you can see what is replaced, just so you don't have to go fudging back for all the videos. Hang on a sec. I've got some pictures on here I don't want getting shown. Okay, here we are. Okay, you can have a look at this one. That's no big deal. I'll get onto it. There we go. Up we go. Up we go. There it is. That's one that's gone back to a dealer, so I was told, in my best belief it was. But you can see the DAC chip there, and those two brown inductors. That's all they are. They're just inductors. So yeah, I can't even work it. I think it's got a branding on it. It looks like an S or something on those inductors. I don't even know if it is, or unless they ground the ID off them. I don't know. It's a. I don't know if they would do that. I don't know. What is that? What is that symbol? That's actually a damn good question, isn't it? What is that symbol there on those devices? I don't know. It looks like, yeah, I got no idea if it is a symbol or if it was given a touch of the Dremel or something. But yeah, I'm not going to make it, like I said in the other video, I'm not going to make any more comment about that picture. All I will say is that I did not do that, right? That is not my handiwork. And you can just, yeah, see it for what it is. But yeah, that is the DAC3. Oh, I can't see it through that. I think that's resin or some sort of soldering paste that was put over there. Hey, look, it could have been, I'm just guessing, aren't I? Yeah, some way and means to protect the other components if they used a hot air tool getting the original devices off. But yeah, I don't know. Anyway, that's that. We've got a nice clean one over here. I'll zoom this back out because otherwise we'll have too much movement. Whoops, that's too far. We'll go back to 1 to 1. I think it's there. Anyway, car sickness time, I call it. Moving the tripod in this room without bumping things with its big tripody legs. There we go. But what I'm going to do on this one, I might actually drop one of those inductors out and we'll see what it is. We'll just measure some bare basics on it. Oops. It's a bit difficult doing that. There. So what I'll do, I'll just I'll put some extra light on here. I'll just drop him out and I'll put him on the LCR bridge and just see what he is. I don't like measuring these things in circuit because with all the other components hanging off, it'll give you a false reading. You won't know what you're doing, really. I'll just turn that meter off there. I don't want that on. Okay, I'll use some low melting point solder to get this off. And I'll just drop one of them off. Now I'll do it the nice way. Okay. I really got to turn the board round to do this. Facing me. That'll do. I don't want to blob the legs on the DAC or anything like that. But we'll see how we go. It's very glued on as well, so I'd have to break the glue bond. Yeah. It'll come. I could really heat the iron up and do this. There we go. We're off. And I'll just clean that up later on. But I didn't make a mess. It came off quite cleanly. So we'll get our... now we'll try again. I'll see if I can find my LCR bridge, which is over here. We'll just have a quick poke and just see what value it is. Just in case you get one of these or you buy one second hand and it still has these inductors in there. If you want to change them to low microphonic type, low profile inductors of some description, you can do. So we've got to take into account there's going to be a little bit of inductance in the wires here. So I'll just short these out and we'll see what we have to get rid of. It helps if I was on L. I pushed it onto capacitance. L. Why can't it be I? Anyway, let's have a look. 0.0 microhenry, so there's nothing in those leads. So we'll just stick it up there. Now, these are pretty forgiving measuring these things, even low values. I'll just come in like that. Hopefully it doesn't flick off sideways. I'll rest it on the button over here. And yeah, we'll have a look. These things are magnetic. My God, they're meant to be stainless steel. Whoops, don't do that. Hang on a second. Hang on a second. Please stay there. I should glue it down on something, shouldn't I? We'll just measure it. Come on, get on there. Okay, now I've got my fingers in the way so I can't read it. Oh, okay. It's 8.9 microhenries. So I don't think there is a value of 8.9. It's probably 8.8 or something of that nature. They are standard values. So it is 8. I thought it was 2. I was only guessing, but it's 8.9. It's got a Q of 2.270 at 1 kilohertz. If that means anything to you guys, but not necessarily. So yeah, 8.9, 9. It could be 8.2, 8.6, something. We could actually test that to see if it's microphonic, just by connecting that up to the a little amplifier, stick it on the amplifier to the oscilloscope, and we can just add some close proximity audio to it, or just vibrate it with something mechanically and just see if it's microphonic. It's always struck me that something so small could be microphonic. It has got a lot of wires and little coil of very, very fine, thin wire in there. That's what it is. Anyway, that's a better way of taking them out rather than using a hot air gun and cooking everything. Yeah, much safer. You can do it with the iron. If you actually get an iron, it's got 2 tips on it, 2 tips that suit something like this. You can heat the whole thing up and just wiggle it until you just see it move a bit, and then just take it out. But we did it that way instead. But yeah, that's what they are. I probably have some I can replace these with some different type of inductors, but that's what they are. In all fairness, possibly, and I don't know if anyone's ever tried this, because I know they just swap them. They put in different devices, but maybe they do put lower value ones in there. Why have I got 2.7 in my head for? I really don't know, but it's floating around there for some reason. Maybe if you do have a lot of inductance there, a lot of winding, you can get a lot more vibration and coupling, because it's just basically more turns to wiggle. That's one way of putting it. And with a lower value inductor, if it doesn't make much difference to your sound recovery, swapping it from digital into a sort of analog type of signal, well, maybe you don't need that much inductance. Maybe you can get away with less, and it does cure it. These are the things I don't know, because I've never done the experiment. I could pull these out and I could put some, put some whatever's in there, 12 or something, and higher values, more turns, and just check it for microphonics. Put it back together, make it work, see if it's microphonic, then try it again with something smaller. I just don't know, but yeah, for some reason it rings a bell that I've come across 2.7 for some reason. It just might be. I don't know, but anyway, it's something you could experiment around with by changing the values there. If you look at these things, you would possibly put in more inductance to make the sound more rounded, have a less sort of a sharp profile, and it depends on the frequency ranges of the sound you're listening to as well. There's a lot of things you've got to take into account. you've got these capacitors there as well. I haven't checked exactly where they are in the circuit, but I would say that those capacitors are on the end of those inductors and smoothing out, or attempting to smooth out, or whatever they're doing to the audio. You could put bigger ones in there if you wanted to, if you could fit them in. There's probably a bit of room on the end of the board. You could just piggyback them on top if you wanted to, but do it at your own risk. I haven't done it. I'm just throwing ideas out there that are logical for experimentation. You want to do it, you do it. The other thing you could do as well, if these devices here, if the existing ones somehow exhibit some microphonic properties, well, how about just put a great big whopping dob of super glue, not super glue, sorry, I mean hot melt glue, a very sort of a rubbery type hot melt glue. You can get hot melt glues in different, well, it has different properties. So some of them are very hard, some of them are very tacky, some of them, are very like rubbery, and some grip like hell, and some don't. So there are. We got our last lot of hot melt glue. We got a different lot of them. I think for radio spares, they had lots of different types of hot melt glue. And we got some that were yellow, some that were clear, some that were opaque, some that were black even. And they all had different properties. So, you could put a blob of hot melt over it, and if it's microphonic, that may cure that issue. But then again, these aren't that far away from, not when you think about it, it's not far away from the speaker, right? So even though it's a very, very low profile magnet on that speaker, is that enough leakage there, like electromagnetic energy from that magnet and the voice coil, causing a fluctuating field that is then cutting the windings in these inductors. Cutting means inducing a field in these inductors here, and it's causing a feedback oscillation that way. If that is the case, putting hot melt glue on them or something is not going to do anything. It's going to do jack with the S word. So it won't cure it at all. So yeah, but I haven't worked out the mechanism for it. I just haven't done it, so I don't know. I'd say Minelab have, and it's just my opinion, of course, that they haven't put big dobs of hot melt glue over them, which could indicate that it may be magnetically or electromagnetically coupling in and inducing a voltage on a speaker and causing a feedback loop. That could be the other possibility. Thus, I wish I had, well, they're all gone back to customers now, but if I actually had one of these that had been replaced, and I actually said to myself, well, I'm going to pull that out and measure it and see what it is, then I would know. And I could give you the definitive answer of more than likely why they were replaced to what they were replaced with, because I don't know the values of the other ones. I would have thought they would have been the same, but then again, if it's a magnetic coupling thing, they will use a lower inductance because there's less coupling. It's like winds on a coil, or a transformer. Same sort of thing. The more winds, the more coupling you're going to get. So that's that. Anyway, if I'm going to go and do all these little test things on this, it's going to take ages to do. There's a lot of setup and mucking around. It's going to bore the hell out of everybody. So I'm not going to video that. I'll just do it, and I'll make my own assumptions on it. The other thing I could do too is I could probably get one of these inductors, put it at the same spacing as the speaker, power the speaker with some audio separately, and use this onto a little preamplifier, put it into the oscilloscope, and have a look and see if we can get any induced fields into this inductor and see what happens. Or even so, it might be better to probe on the board here, whilst this is off, of course, just in case all the track work is causing some coupling as well. You know, it could be a mixture of the inductance of the inductor and all the hanger-oners with the capacitors, and that setting up some sort of tuned circuit that's you know, partially resonant with the flux out of the you know, the voice coil from the speaker, you know, just causing a feedback loop. I don't know. My opinion. Okay, I'm allowed to have an opinion, but I don't know. I've never done the tests. Oh, I'm feeling tired. It's yeah, starting to head towards 11 o'clock, so I might pack this one up. By the way, if you want to know, I might add this in just on the end of this, of course, because no one will ever be watching this to this stage. So the last video I put up, it was done a little while ago, but I only put it up yesterday, on the GPX6000 against the other GPX7000, one that I modified up, one that was standard. I did the standard one and I modified it to exactly the same as I did the other one, and it came up exactly the same as the other one, as the first one I did, which proves a point. Now, that's gone back to the customer. That went back to the customer last night. And David deals with the customers, as you may know if you deal with us, because I'm just too busy doing this R&D and work stuff and whatever else is going on. And basically, it went out in the morning and found its first bit of gold after the modification. And it wasn't a big lump, it was small, but the guy was impressed. So anyway, I was meant to get an email about that. I was going to get an email with a picture and a spiel, and David was meant to forward it, but he hasn't done it. I don't think he's done it. Maybe I should go and have a quick look. Should I have a quick look? I'll go have a quick look. Hang on, I'll get back over on the computer. Just see. Oh, here we go. A bit of roaming around the thing. I don't want to show all my emails on here because there's some stuff there which we could classify as a bit secret at the moment. But I'll just make sure. Hang on a sec. Oh God, so many emails already. Where's someone wants to connect First National Real Estate Maryborough? First National, you want to buy a house in Maryborough? $315,000 for a miner's cottage? No. Your delivery from something's been something. Yep. Yeah. Okay. Yeah. Okay. LD. YouTube. World Economic. Oh, and he's a Chinese company sending me information on Litz cables. Oh, free sample. Yeah. Yeah, they're Litz cables, all sorts of stuff. Very small ones. But anyway, no, you can have a quick look. I can't show you my email list. There's just too much there. There we go. There you go. All sorts of Litz type cables. Anyway, I just can't. And someone on my other video was saying, why don't I use the yellow core? Why did I use this core? First of all, this one's bigger. And even though this one's painted bright yellow, I'd use the big one because it has a higher permeability and it completely tickles those 7000s to try or attempt to ground balance on it. It gives it a really hard job to ground balance on that core there rather than that core there. That's got very low permeability. It's probably, I don't know, it's about 20 or something. This thing here is a hell of a lot higher. normally it would be equivalent to the worst ground you could subject that detector to. This is mild. This is just normal. It would just be simulating relatively medium to sort of medium high hot ground. This thing here is off the chart. So if it can even attempt to ground balance on that, the reason I use that is out in the field is because I want to see how the detector is going to behave on something like that and see if it can actually get very close to ground balancing, or if it can't, right? It gives me insight to how well the electronics is working. If it's got a better ground balancing ability, this is a walk in the park. It's nothing. It's not stressing anything, and um, yeah, so that's why I do that. So someone was asking and saying, "Why'd you do this?" And you didn't use the one MindLab used anyway, guys. They call them ferrites. They're not ferrite. They are not. I will swear on a stack of Bibles that these are not ferrite. Have a look at what ferrite is and have a look at what powdered iron is. It's powdered iron is not ferrite. Okay, so I just want to get that thing. Everyone's going on and on about ferrite. It's not ferrite. It's not. There's two families, actually. There's a whole heap of families of cores. You've got, permalloys. You've got things they call sendust, which is a Japanese invention. They used in heads of, cassette tape recorders at one stage, and they also used it in video. Big video stuff in TV studios back in the 80s. I remember fixing stuff like that. Yeah, and anyway, there's a whole heap of stuff. There's all your magnesium, zincs, and there's other exotics, cobalt in it, and you get different families, of course. So ferrites are a particular thing. They're not powdered iron. Anyway, get back over here. Sorry for being pedantic about that, but it's just it's like I don't know. I don't know how to classify it to anything. It's like I don't know. It's just a different family of things. Okay, so anyway, we're back on here. I'm going to go and rip into this. Well, not really, but I'm going to do a lot of work on this detector. This has come in for the. I've done one for this guy already, and he said that the one he got back from me absolutely. Well, I won't use his words, but it was a lot better than this one. So this one's getting the same treatment. So he's got two 6000s that he'll have done. I'm glad that he actually got one done, and he was able to compare it like to how it was, and he said it's a lot quieter and works a lot better than what this one does. And this one I'm going to make the same as the one he's got now. So yeah, that's where we are. Anyway, I sort of want to get into this, but also I want to stop work. I'm in a bind between two places. But I'll do a little bit more. I'll probably work to about 11:30 or something. So I better stop making videos. And yeah, anyway, we'll see how this comes up. Hopefully it comes up as good as the other. Pretty sure it will. But I'll go out the test site and make a video at a test site with this and just see how it all goes. Anyway, catches.